Let's start the homework video guide on related rates. And for this very first problem, we have a 3D cube. And in this problem, we're given that the sides of this cube are increasing at a rate of 0.2 centimeters per second. And for the first part, I want to find out how fast is the surface area of the cube increasing the instant when the sides are 10 centimeters. Okay, so for these related rates, it might be a good idea to set up a find, when, and given section here on the left-hand side. And let's go ahead and fill this part in. So for part A, we're trying to find how fast the surface area. So we're trying to find how fast the surface area is changing. So we need to find dA by dt. And I want to find out when that's changing when the sides are 10 centimeters. So this is when the sides are 10 centimeters. And what rate are we given in the problem? Well, we're given that the sides are increasing at a rate of 0.2 centimeters per second. So the way I kind of write that out is I usually take the number, which is 0.2, and then I write out the units, which is centimeters per second. And then I just create my derivative expression over here. So if I have seconds on the denominator, I know I should have dt on the denominator over here. And since it's sides, it should be ds. All right, the sides are increasing at a rate of 0.2 centimeters per second. So that way you can see that the units all match up. Okay, so once we have all that, we need to find a formula that kind of relates all of this. And since we're dealing with a 3D cube, we need to find the surface area of a 3D cube. So if I take a look at this front piece right here, the area of that is just length times width. So it would be s times s. And you have to recognize that you have 6 sides. There's 4 on the side, and there's a top and a bottom, so that's 6 sides in total. So your surface area expression is area equals to 6 times s squared. So remember, for that particular formula here, s squared is the surface area for one side. And then you have 6 of them in total, right? There's 4 on the side, and there's a top and a bottom giving you 6 in total. Okay, so from there on, you can now take the derivative here. So the derivative of area with respect to time is going to be dA over dt. And since I have a constant of 6, the 6 can remain on the side. And then the derivative of s squared is going to be bracket 2s times ds over dt. And then from here on, you can just plug in the numbers, and then you should be done. So if I just plug in the numbers here, I have 6. And that's going to be multiplied by the 2. And this side is going to be 10, right? So we were given that the side is 10 here. And ds over dt is the rate that's been given to us, which is 0.2. And if you go to a calculator and if you go to a calculator here and multiply all this out, you should get 24. And the units will be centimeters squared per second. Remember, we're trying to find dA over dt. So if you line up the units here, time should be on the bottom, and since we're dealing with area, the units should be centimeters squared there. So for part A, the answer is 24 centimeters squared per second. Okay, let's move on to part B. So part B is the same kind of problem, but we need to find how fast is the volume increasing the instant when the sides are 20 centimeters. Okay, so for part B, I need to find dV by dt. I want to find the rate at which the volume is changing when the sides are 20 centimeters. And for this particular problem, I also know that the sides are increasing at a rate at 0.2 centimeters per second. Okay, so we're given that ds over dt for this problem is also going to be 0.2 centimeters per second. Okay, and since we're trying to find dV by dt, I guess the formula that relates everything together should be the volume of a cube. So the volume of a cube is just length times width times height. So here's your length, here's your width, and there's your height. So if I multiply all that out, I should get s to the power of 3. And if I want to find the derivative of volume with respect to time, that's going to be dV by dt. And the derivative of s cubed is going to be 3. Whoops. It's going to be 3 s squared, and then by using the chain rule, we need to multiply by the derivative of s with respect to time, which is ds over dt. Okay, so there's your derivative of your volume expression there, and after that, we just kind of plug the numbers in here. So we have a 3, and what is s? Well, s is going to be 20 here, so I'll put a 20 for s. And we know that ds over dt is going to be our rate, which is 0.2. And then from there, you can just kind of plug that into a calculator. And once again, if you go to your calculator, you should get 240 centimeters cubed per second. And once again, this is a dV over dt. So just make sure that your units, if this is volume, then that should be volume as well. If this is time, that should be measured in time, and that should be measured in time as well, or a unit for time, which is seconds. Okay, so not too bad for that very first question to open up the relator rates homework questions here. Let's keep on moving along here. In this question, I have a spherical snowball. So the area of a melting spherical snowball decreases at a rate of 2 pi centimeters squared per minute. So that's the area that's decreasing, right? And I want to find out how fast is the radius changing. So keyword, how fast is the radius changing? So I need to find dr over dt. And that I want to find that exactly when the radius is equal to 3. And the rate that's given to me, well, let me start with the number here, which is 2 pi. And the units are centimeters squared per minute. Okay, so if I just line up the units here, minutes should be time, so this is dt. And since I have a squared there, this should be dA, right? dA over dt. And just remember this question says decreasing, so there should be a negative sign for that rate as well. All right, so those are some strategies in terms of writing out the information that's given to you. And I want to find dr by dt. Okay, so not too bad here. So I would say for this particular question, you definitely need to know the area of a spherical object here. So it's just not a circle, it's a 3D circle. So the area of a 3D circle, which is called a sphere, the surface area for that is area equals to 4 pi r squared. All right, and if I want to find the derivative of this, this will be dA over dt equals 2. Now I have a constant here, so let's just move the constant to the front as 4 pi. And then what's the derivative of r squared? Well, that's going to be 2r times dr by dt. Okay, so after that, let's go ahead and figure out what's happening here. I want to find what dr over dt is. And for this particular problem, I guess I'm given that dA over dt. We're given that value as negative 2 pi. So the way you kind of write that in is negative 2 pi equals to 4 pi. All right, so I'm just kind of plugging in the numbers here there. And then I'll put the brackets in here, bracket 2. And the radius, I guess, is going to be 3, right? So I'll put a 3 there. And then times this by dr by dt. All right, so that's what the expression will look like if I plug in all the necessary numbers here. And just remember the radius was 3, right? So that's where that 3 comes from. Okay, so hopefully that makes sense in terms of plugging in the numbers. And then now we need to simplify this. I see that that pi and that pi can cancel out. And I have a negative 2 here. And 2 times 3 will be 6. So and if I apply, sorry, I forgot the 4, I guess, so maybe I'll erase this here now. Yeah, 2 times 3 was 6, and 6 times 4 is going to be 24. And then I guess you can divide both sides by 24, so I have negative 2 divided by 24 equals to dr over dt. And if I go ahead and use proper units here, this would be negative 1 over 12, and my units should be centimeters, centimeters per second. Okay, so once again, centimeters matches the radius, seconds matches the time. All right, so those are my units for that particular problem. So yeah, the first 2 problems, not too bad to start the relator rates homework section guide here. Okay, let's move on to this. Let's move on to the triangle problem. And for this triangle problem, it states that the height of a triangle is increasing at a rate of 2 centimeters per second. So let's put that in right away. I know that the height, so dH over dt, the height is increasing at a rate of 2 centimeters per second. And the base of the triangle is decreasing at a rate of 3 centimeters per second. So the base is changing, right? So that's going to be dB over dt. And that's changing at a rate of negative 3 centimeters per second because it's decreasing. And I want to find out how fast the area, okay, so the area is dA over dt. I want to find out how fast that area is changing when the base is 8 and the area is also equal to 40, I guess. So there's a lot of things going on in this particular problem. We want to know how dA over dt is changing at a very specific moment, and that moment is when the base is 8 and when the area reaches 40 centimeters squared. All right, so while we're dealing with the area of a triangle here, so the area of a triangle is 1/2 base times height. Actually, maybe I'll write over here. So area equals to 1/2 base times height. And let's go ahead and find the derivative of this, and we'll notice that we'll run into one little problem for this particular case here. So I have dA over dt equals to, now there's a constant of 1/2, so I generally pull that constant to the side there, and then I take the derivative of the variables by using the product rule here. So the derivative of b is going to be dv over dt times the height plus the base times the derivative of height with respect to time, which is dh over dt. So there it is. There is your product rule being applied there, and we'll have the 1/2 on the outside there. Now the problem with this derivative expression is that you can plug numbers in, but you actually don't have the height. So you do need to find the value of the height because that's not given to you. And what you have to do is you need to create another helper equation here. And the helper equation is still the area equals to 1/2 base times the height. And when we go over to this section of the when section, we know the base is 8 and the area is 40, right? So we have to use that information to find the height. So when the area becomes 40, we know the base will be 8, and we need to find the height there. So this will be 40 on the left-hand side. This will be 4 times h, and it turns out that our height is going to be 10 there. All right, so we're going to use that 10 to replace for that variable of h right there as we finish off this particular problem. Okay, so once again, we want to find how fast the area is changing under these parameters, and after that we can plug in the given rates here. So if we go ahead and do this, I guess we have 1/2 bracket, and the base is changing at a rate of -3 centimeters per second. The height was 10. The base in this problem is going to be 8, and dh over dt is going to be 2. All right, so once we plug those kind of numbers into your calculator, we should get -7 centimeters squared per second here, and this is going to be dA over dt. And once again, I just look at my units here, and area matches centimeters squared, and seconds does match time. So that answer should be appropriate for this. This answer should be okay for this problem. Okay, let's move on to another related rate problem. We have a spherical balloon in this problem, and it's inflated with helium at a rate of 36 pi centimeters cubed per second. So whenever I see those kind of numbers, I don't mind writing them out right away. I have 36 pi centimeters cubed per second. And if I align this up, this should be dV by dt. And just because I have cubic centimeters there, so that should be volume, right? So make sure your units do line up. And I want to find the rate of change in its surface area. So I need to find dA over dt. And I need to find that exactly when the radius is equal to 10. Okay, so definitely a lot going on in this particular problem. The two formulas that will come into mind when you're dealing with this particular problem, and since you're dealing with a sphere, is that you need to know the volume of a sphere, which is volume is 4/3 pi r cubed. And later on, you also need to use the area of a sphere, which is 4 pi r squared. So those are the two formulas that you'll be working with to find dA over dt. Okay, and the variable that kind of links both of these formulas together is the r variable, right? So our first goal is to find dr over dt, and then we can find dA over dt. Okay, so I'm going to rewrite again. I'm going to rewrite the volume of a sphere over here again, which is 4/3 pi r cubed. And if I find the derivative here, I should get dV over dt. And my constant is 4/3, so the constant will move out in front, and the pi. And then what is the derivative of r cubed? Well, that's going to be 3r squared times dr over dt. And then I can close that bracket. All right, so let's go ahead and figure this part out. If I look at the dV by dt, we know that's going to be 36 pi. So let's go ahead and insert that in. That's going to be 36 pi. And that's going to equal to 4 over 3 pi. And then if I multiply the numbers, there's a 3. And what's my radius? My radius is 10, right? So this will be a 10 squared times dr by dt. Okay, so it's very important to find dr over dt. Let's just see here. I guess the pi's will cancel off. The 3's will cancel off. I guess there's a 36 here. 4 times 10 squared is going to be 400ths. And that'll be dr over dt. And after that, I guess if you divide both sides of the equation by 400, we get 36 over 400. And the units for that should be centimeters per second. And I guess dr over dt, if we continued here, I guess 36 over 100 is going to be 9 over 100 there. Okay, so now that I know that, let me box this. And remember, we know that the area of a sphere is 4 pi r squared. And then let's go ahead and find dA over dt now. My constant in this case is 4 pi, right? So let's put the 4 pi out in front. And the derivative of r squared is going to be 2r times dr over dt. All right, so this is looking pretty good now. So I need to find dA over dt. So this will be 4 pi. The 2 will be there. Now, what was the radius in this problem again? Well, if I go back to the beginning of the problem, the radius was 10, right? So the 10 gets plugged in again. So this will be 10. And finally, dr over dt, this will be 9 over 100. And with all that, you just want to multiply that out, and hopefully things will work out. I guess I have, I don't know, 2 times 10 is going to be 200. And then I guess if I, actually let's just multiply it all out. So go to your calculator and multiply all that out and divide by 100. And if you do that, you should get 36 over 5 pi. And the units should be centimeters squared per second. And that's going to be dA over dt. Okay, so a little bit of work in terms of getting the 36 over 5, but if you're not sure with that, just use your calculator for this homework question there. Okay, let's keep on going here. I guess I have a cylinder now to kind of finish off the first set of homework problems for the related rates homework guide. And for this cylinder problem, I guess that we're given that the volume is what? Okay, so we're given the volume right away. So the volume of this is 240 pi centimeters cubed. So maybe I'll put that to the side here because I'm pretty sure that's going to be used for the helper equation later on. So the volume is 240 pi centimeters cubed, and it's stretched out at a constant rate of 6 centimeters per minute. Okay, so I guess that if we read it very carefully, it says the height is stretched out at a constant rate of 6 centimeters per minute. Okay, so we're given that dH over dt is going to be 6 centimeters per minute. Right, and the volume of the rubber tube does not change. Okay, so that's important. The volume of the rubber tube does not change. So that means dV over dt is going to be equal to 0 as it stretches vertically, and we need to find the rate of the change in radius, right? The change in radius. So I need to find dr over dt, and we need to find that exactly when the height is equal to 15. Okay, so this is really actually not a hard problem because the formula that we need to relate all of this is the volume of a cylinder, which is pi r squared. That's the area of the circle, and we just times it by the height, right? So that's the volume of a cylinder there, and we're just going to take the derivative of that, and then we're going to probably use the helper equation to find one of the missing unknowns. Okay, so let's go ahead and find the derivative over here. So let's use another line over here. This will be dV over dt equals 2. Now the pi is a constant, so I'll leave that out. And then let's use the product rule here because I have r squared times h. So if I use the product rule, that should be 2r times dr over dt times the height plus r squared times dh over dt. Okay, so that right there is the derivative right there, and I guess when we're plugging things into the expression here, we want to make sure that we can also find some of the missing unknowns here. So let's just go ahead and start plugging in some numbers, and then we'll find the missing variable that we need to find here. So we know the volume is not changing, so 0 equals to pi times 2 times. Now, what was the radius? Okay, so I guess we don't know what the radius is, right? So we need to go ahead and find the radius here. And we're definitely going to be using our helper equation here. We need to use our helper equation to find this missing radius right there. So back in the original problem, we're given that the volume was 240 pi. So we're going to go ahead and create the helper equation over here, which is pi r squared h. We know the volume is 240 pi. And I want to find the radius, and we should also know our height, right? So the height that we're given in this particular problem is 15, right? So we'll be using the height of 15 to help us define the radius there. And if you clean that up here, I guess r will be equal to 4, and that 4 will be substituted for this r over there. All right, so that is your helper equation over here to help you find the radius. Okay, so let's go ahead and plug in the numbers here. So 2 times 4. And dr over dt, well, where is dr over dt? Well, that's exactly what we need to find, I guess. So I guess I'll write that as dr over dt. The height is going to be 15 plus the radius. Well, the radius was 4 squared. And dh over t is going to be 6. Okay. So we do all that math there, and our goal is to find dr over dt. And since the left-hand side is equal to 0 here, we shouldn't have any problems finding dr over dt. So let's go ahead and figure out the numbers here. I guess you can multiply all this out here. So I guess if I take 2 times 4 times 15, if you look at your calculator there, that's going to be 120. So this should be 120 pi times dr over dt. That equals to 0. And then I have the plus. Then we have the 4 squared times 6 there, and that's going to be plus 96 there. Okay, so now now our goal is to continue to solve for dr over dt. Bring the 96 over, so I have negative 96 equals to 120 pi times dr over dt. And dr over dt is going to equal to negative 96 over 120 pi. And that's going to be in, sorry, I guess I've got a pi over here. Sorry, there's one more pi over here that gets distributed there, so that should be a pi there and a pi there. And I guess my units here will be centimeters per minute. And from there, I guess the pi's will cancel, and you should get a final answer of negative 4 over 5 centimeters per minute for dr over dt. Okay, so I apologize for missing the pi there, so make sure that we distribute that pi right through, and that should take care for that. That should do it for this homework video guide.